We are going to do some practice free fall problems. So the first thing I want to explain is what free fall is. Free fall is any time the only thing acting on an object is gravity. Object is in free fall. So if I throw a ball up, it's in free fall as soon as it leaves my hand. If I drop a ball, it's in free fall as soon as it leaves my hand. It doesn't matter if it's going up or down. Say, for example, a baseball pitcher. When a baseball pitcher throws a ball, it doesn't matter how much power he has behind it. As soon as the ball leaves his hand, the ball is considered to be in free fall until the catcher catches it or the batter hits it. So free fall is any object where the only force acting on it outside of air resistance, we neglect air resistance, but the only force acting on it that we're concerned with is the force due to gravity. So you always want to start by writing your three equations for kinematics. So VF equals VI plus AT. VF squared equals VI squared plus 2AD. And D equals VIT plus 1/2 AT squared. Okay, now let's read the question. A student throws a coin vertically downward. As soon as it leaves the person's hand, even though they're throwing it down, it is in free fall. From the top of a building, the coin leaves the thrower's hand with a speed of, so I like to draw a picture of what's going on. So here's my building. Here's the person. They threw a coin and the coin is going down. Speed, so the initial velocity of the coin is 13 meters per second. What is its speed after falling freely for a time? 1.8, that should be 1.80, ignore that. 1.80 seconds. And we're trying to find its speeds. We're trying to find its final velocity equals question mark. Okay, so if we're going to find the final velocity, we need to know VI, which we know, A, and T. Here we need to know A and D. All of these have A in it. Well, what's acceleration? Well, if it's in free fall, the only thing acting on the object is the force due to gravity. So that means acceleration is always 9.81 meters per second squared. Now, usually we make positive up and we make negative down. So because I threw the ball down, this actually becomes a negative 13. And because gravity always pulls things down, it becomes a negative 9.81. And our final velocity will also be going down, so it's going to end up being a negative number. So if I look at these four variables and I match them up with one of these equations, they match up with the first equation I have written here. So I'm going to rewrite it. VF equals VI plus AT. So now we just plug our numbers in. The final velocity, or VF, that's what we're trying to find. Our initial velocity is negative 13, plus our acceleration is negative 9.81, times time, which is 1.8. So our final velocity is, get our calculator here and do some math, 1.8 times 9.81 equals, it gives me 17, and remember it's negative 17.658, and minus the 13. Okay, so our final velocity then becomes negative 30.7. That'd be meters per second. Now, these questions are multiple choice, so you want to make sure that the answer you choose is as close to this as possible, because there could be some differences in terms of rounding or something along those lines. So if you choose the answer that's closest to negative 30.7, you'll be good. Oh, one last thing is it says what's its speed. Speed is not a vector, so we can throw the negative out. So you can just say 30.7. But the correct answer would be negative 30.7 for velocity. So